Alright, here we are solving a problem with a linear moving object, a ball of clay maybe, colliding with a stick, and it's free to rotate, and the angular momentum is going to be conserved, and the angular momentum of the ball is r cross p, and we're going to equate that to the angular momentum, which is rotational inertia times the angular velocity of the system afterwards. So to get r, you have to find out that distance from the new center mass to where the ball hits. So you have to calculate center mass first and run through, and we find out that the center mass is going to be 4.3 meters from the bottom of the stick. That's what I use for my frame of reference. So r is the distance from that center mass point, and if it hits at 2.5, that's going to be 1.8 meters. And then we can find the momentum of the ball coming in. So we know that the rotational inertia of the system is the rotational inertia of the stick plus rotational inertia of the ball. And that's as measured around this new center mass point. To get the rotational inertia of the stick, we've got to do some calculus. And we know that our density is mass per length, or dm over dr. And we need to do this so that our variables match. So as we go through, we can integrate, and we find out that it's lambda 1/3 r cubed, and our limits of integration are negative 4.3 the bottom end to 5.7 the top end. And that gives us a rotational inertia for the stick of 44, and then for the ball it's just a simple point project, so it's mr squared, and that gives us 6.5. where we now have a rotational inertia of 50.5. And then we can do just an easy algebra step and find out the angular velocity after the collision is 1.07 radian per second.